So Shravya and Heer, you guys are planning to come over to the classroom soon? Maybe. Okay.
Yeah, maybe.
Okay. No, that's fine. So I'm kind of arranging the classroom for you guys. Whoever is coming over, and again, this is just an offer for you all. I know some of you have subscribed for being online. Some of you are choosing to come in person. But whoever is in Dallas, and even if you have subscribed for being online, and if you happen to come to this side and you want to attend few classes in person, please, I mean, you're more than welcome, because I'm kind of settling down the class, trying to make it look more like a classroom. So, and tell your parents that no, it doesn't, your fee structure doesn't change. I mean, anybody stopping by for joining a few classes in person versus being online, it doesn't really hurt anything else. Okay, so don't worry about that. So even let's say Arya or Ananya, if you guys ever plan to come to Dallas for a small trip, stop by and we can attend few classes in person also. All right. So that was on the information front. Let's get started. So who all got a chance to see what all we're going to cover today? Nobody? Okay. Let me read it for you. So the thing that we're planning to cover today would be quadratic graph functions, trying to figure out maximum minimum value for x and y coordinates, finding out the x-intercept, y-intercept, finding out vertical symmetry. And for some of you, you would have probably heard this in the previous classes, but it will be more of a recap. And then we'll talk about the different forms of quadratic functions, and how do we relate that with a graphical scenario, in this vertex form, or in the standard form, or in the factored form. Okay, and then we'll try talking about rewriting quadratic equation to get properties of parabolas. So that is at a high level what we are going to cover, and it's again part of Unit 4. So for Dhanushri, for Pranit here, Srivatsa, Vaibhav, so you would have probably come across these concepts in the previous classes, but I have kind of done a deeper dive into these chapters one more time for you guys to see if we can get some more meaningful or interesting facts out of those topics, and then see how do we use that to build our concept. So some of the things, if you find relatable or that you have covered in the past, don't worry, it's going to be more of a revision, because right now we are doing Unit 4, and then we'll finish off this one to logical point, then we'll go to Unit 5. So that's how we'll continue. Okay. So again, it's not like a one-time concept, right? I mean, everything that we learn in math, we'll have to keep on practicing. We'll have to keep on revising concepts, so that when you go for a city exam, it sounds something you have done it enough, right? So bear with me. There's something that you hear from me, which is a repeat telecast of what you've heard before, but then it's an opportunity for all of us to kind of relook at those concepts and make sure that if there was something that we assumed, that gets knocked off. All right? Okay. So are we all ready to start? Everybody with me?
Yes, sir.
All right. And I would request you all, okay, let's keep this class as engaging as possible, meaning keep asking questions, keep responding to the questions I ask. So that way I will get that comfort that, okay, I'm not teaching just for being compliant for 1 hour. It should be a meaningful exercise for all of us. Okay. All right. So you all have heard about something called a linear equation. We all know what is a linear equation. A linear equation is an equation where the maximum power to the variable is 1. And what it means to us is, a linear equation helps us draw a straight line. Linear equation has a word line into it. And that's what it means. It helps you draw a line. Now, till I have the power to the variable, maximum power to the variable is 1, it draws a linear, it's called a linear equation, it draws a straight line. That is understood. What happens if I increase the power, same equation let's say, or let me not deal with multiple variables in the same equation. Let me say I have a linear equation, an equation like 3x squared plus 4x minus 17. What do we see here? Here also I have two variables, y and x, and I am saying that the maximum power to the variable is 2. I can also say that this is not a linear equation, it's a linear function, it's not an equation, it's a function. Function of x, y as a function of x, like this. Okay, or keep everything aside. Let's say this, y equals this. If I have an equation like this, this is not a linear equation for sure, because the maximum power to x is 2. It is called on the screen quadratic equation. Yeah. Now, so maximum an equation with maximum power to the variable as 2 is a quadratic equation. Now we all know a linear equation helps us draw a straight line. What does this quadratic equation do? Okay, on the screen.
Parabola.
It draws a parabola for us. And when we say parabola, we are talking about something like this, something like this, something like this, something like this. Everybody with me so far?
Yes, sir.
Okay. Now, so that is where we are going to do more of a post-mortem of this equation, which is called quadratic equation or a quadratic function, whatever you call it. If I put it like this, this is called a quadratic equation. If I put it like y as a function of x equals this, I can as well call this as a quadratic function. Yeah, where y is a function of x with this term or this condition, whatever. Yeah. So we are going to do a post-mortem of quadratic functions or quadratic equations. Let's keep it simple, we'll call it quadratic equation. Now, if I have a quadratic equation like this, it will draw a parabola. Now, we don't know how the parabola will look like. It can draw a parabola like this, or it can draw a parabola like this. Yeah, I mean, we have not drawn it, so we are making guesses right now. If the parabola is facing upward, I mean, the difference between these two scenarios is, between these two parabola is, this is facing upward and this is facing downward. Is that making sense?
Yes, sir.
Now, let's look at some of the properties of the parabola. Let's try understanding, if I'm looking at a parabola, what are the things that I need to be aware of? First of all, parabola has one unique thing about it. There's something called a line of symmetry. Meaning, you can literally break the parabola into two equal parts. And that will be this line, which will break the parabola into two equal parts. And this line is called line of symmetry. So here in this case, there will be line like this, which, I mean, again, my drawing skills are questionable. So, let's say this, okay? And you'll have to probably believe or trust me based on what I say, okay? Don't trust my drawing skills. If I am not drawing it correctly, you'll have to believe my words, okay? So here, This is a line of symmetry. Even if it doesn't look exactly the way I'm saying it, this line of symmetry is the line which splits the parabola into two equal parts. One this side, one this side. And you can treat them like a mirror image. So if we talk about line of symmetry for a parabola, it's a line that splits the parabola into two equal parts or two parts which are mirror image of each other. Is that part okay? Clear so far?
Yes.
Yes, sir.
Yes, sir.
Now, there's one more thing you will see in the parabola. If I have a parabola like this, do you guys know what is this point called?
Vertex.
Vertex, which could be the lowest or the highest point, or lowest or highest value of the y coordinate of the parabola. If the parabola is facing upward, this will be my lowest point, the lowest point of y coordinate. Meaning this point will have x and y value, right? Every point on the parabola will have x and y value. This will be the point which will be the lowest point of the y coordinate. Okay? Or the lowest value of the y coordinate on the entire parabola. If my parabola is facing downward, that means the vertex will be the highest point or highest value of the y coordinate. That's how we'll relate it. Is that part okay?
Yes.
Now, there are few more things that we want to talk about. When I'm drawing a parabola, I'm not saying the parabola will be always here. It can be here, it can be here, it can be here, it can be here also, depending on how your equation is constructed. So, let's say the parabola is here. What do you see? These are the 2 points where it is touching or crossing the x-axis. Those are called x-intercepts, meaning the intercepts or the touching points of the x-axis. Similarly, you see here, this is the point where it is touching the y-axis. So the parabola may or may not touch the x-axis and y-axis depending on how the equation is constructed. Okay. But if it does, those will be called x or y intercepts. Is that part clear so far?
Yes.
Everybody? Shravya, Heer?
Yes, sir.
Sir.
Yeah.
Yes, sir.
Okay. I know it's post-lunch session, so it could be little bit, what you call, you might be feeling a little sleepy like I am feeling right now, but I have woken myself up. I'm just trying to make sure that everybody in the class is awake. Okay. Alright. Now, let's look at this equation and try to find out what will be my x and y intercept here. Let's say this is my coordinate plane and the parabola is going like this. What will be my x coordinates? What all would be my x intercepts? Meaning there will be 2 points. Let's say x1, y1 and x2, y2. These are 2 points where it is intercepting the x-axis. Now, when I'm saying that it's intercepting the x-axis, what it means is this is on the x-axis where the value of y will be zero. Are you guys with me so far?
Yes, sir.
Arya, Nanya, Heer, Dhanushri,
Yeah.
everybody?
Yes, sir.
Yeah.
Yes,
Oh.
sir.
Now, so if my parabola is intersecting x-axis at 2 places, this will be my potential value of the coordinates. Y coordinate will be 0 because it's intercepting the x-axis. Similarly, if I ever want to find out where it is touching the y-axis, Let's say it touches here. Let's say, I mean, I'm just forcing this parabola to touch the y-axis. So here, this point, this is intercepting the y-axis. That means the x coordinate will be 0, and there will be some value of y. Let's call it y1. Now, by looking at this equation, can I find out the value of x1, x2, and y? Can we? And you don't have to find it out. If you can tell me how would you find it out, just the approach part of it, just the story side of it. Yeah, correct.
To find your y-intercept, you would put 0 as 2, and that would give you y, which would be -7 because that's...
Say that again. So if I have to find out the y-intercept, what will you do?
Put plug in x as 0,
Okay.
and that would cancel out most of the terms.
And that gives you the y.
-7.
Yeah. So what Praneeth is saying here is, if I have to find out the y-intercept, meaning where the parabola is touching the y-axis, that will be obviously the point where the value of x is 0. If I am trying to find out where the parabola or a line is touching, the equation is touching the y-axis, that means it's touching the y-axis. There is no x value of that point, wherever it is touching, like what we had put here. So that means the value of x will be 0. If I put the value of x 0, this becomes 0, this term becomes 0, this becomes -7. So that means it will be 0 as the value of x coordinate, and -7. These two terms have become 0. So this is -7. So y becomes -7. So now, whatever I did here, that was not correct. Pictorially, right? I'm saying I'm saying that this is y is positive, but from this equation, this comes as -7. That means maybe my parabola is maybe it's touching here. Okay, let's say the x-intercept is 0 here. Yeah, I mean the y-intercept is like this, 0 and -7. So basically it's in the negative side of y. Third coordinate or fourth, it's not third or fourth coordinate, it's touching the y-axis, so it's in the middle actually. Up to this much is clear, right?
Yes, sir. Yes, sir.
Now, if I have to find out the x-intercepts, meaning now my plan has changed, right? Earlier it was looking different. I'm saying it is x2, y0, x1, and y0. Okay? So in this case, let's find out what is the value of x1 and x2. How will we find that out? Anybody on the screen? I'll come to Praneeth later. Yep, yeah.
To find x1 and x2, you can factor the equation above, or you can set y equal to 0 and then factor the equation.
Exactly. So what we'll do is, we'll put y, see, it's very simple, right? You have to just relate. My x-intercept is, so basically when I have an equation, meaning every point on the parabola is following this contract. This is the agreement between x and y. Now, since I'm saying that where it is touching the x-axis, meaning the points on the x-axis, where the value of y will be 0. So that means this equation will transform to 0 equals to 3x squared plus 2x minus 7. That means 3x squared plus 2x minus 7 equals 0. This is my equation. I have to solve this equation and find out the two possible values of x. Since this is a quadratic equation, 3x squared plus 2x minus 7 equals 0, from this I can find out the two solutions that I will get for x, that will be my value of x1 and x2. Yeah? Let's do a quick check. I want to know what is the value of x1 and x2 by solving this equation. Who all can solve it? I'm just doing a quick acid test of this class to see who all knows how to solve a quadratic equation. You guys have only 5 minutes, okay? Yep. Yeah, you had raised your hand.
Sorry, that was just to say that I know how to solve it.
But I want you to solve it. Sometimes I will force you guys to practice a little bit. Yeah? Can you just solve it in the next 5 minutes?
Yes, sir.
And you don't really have to spend a lot of time getting the exact value. Even if you get to a point that, okay, I have this equation now, from this, these are two potential values. I have not solved it to a decimal point, but this is the possible value. If you can tell me that, that will make me proceed further. So not only Arya, okay, I want everybody to do that, okay. So Dhanushri, Srivatsab, Shravya, Narka, Vaibhav, everybody, okay. Here. Try solving this quadratic equation and tell me what are the two possible values of x here, okay. And if you think that you are struggling or you would want me to cover that part, we'll come to that. I mean, I'm just trying to see how much we remember and what we need to kind of learn. Can I assume everybody's trying?
Yes, sir.
Okay.
So I got the answer.
You are the answer. Okay.
Yeah.
I'll just wait for one more of you to confirm, and then we'll take it from there. You also got the answer here?
Yes.
Wonderful. Okay, fine. So we have two kids here who are ready with the answer. Praneet, are you close? Close, okay. So, who can explain this to me? Now it's your turn to teach me. Vaibhav, or here, one of you. Let's go to here then. Here, teach me. How did you solve this one?
If I use the quadratic equation, so I just plugged in the values in the equation and I got negative 5.83, 1.8.
But how did you do it? There are three approaches for solving a quadratic equation. I want to know which approach did you take?
Okay, so I did negative 2 plus minus 2 square minus 4 into 3 into negative 7 over 2 into 3.
I don't think I understood that.
She did this.
Which one?
She just plugged in all
Okay,
these.
so you use the formula like this: x equals minus 2b plus minus b square minus 4ac divided by 2a. Not minus 2b, minus b. Yep.
Yeah.
Okay. So this is one of the form. Everybody knows about this form?
Yes, sir.
Yes, sir.
Okay. Shravya, you're not saying something.
Yes, I understand it.
Yeah, you're fine, right? Okay, okay. So Narka, how about you?
Yes, sir.
Okay. So see again, I'll keep on calling out your names, not to put any of you on the spot, just to get a confirmation for myself that okay, I can skip this. Okay. Dhanushri, you would be knowing for sure. I have bothered you enough with these formulas, correct? Dhanushri is, yep. Dhanushri, you're fine, right?
Yeah,
Yeah. No, I mean, I'm just checking with everybody, okay, just to make sure you guys are the same. So this is one approach, and there are two more approaches. One is by factoring the quadratic equation. How do you create two factors out of it? And second one is by the third one. One is by putting the equation. Second is factoring, and third one is the standard approach. Like we know some of the basic formulas. So whenever we have a quadratic equation to deal with, we try choosing one of the three approaches which helps us solve it for x. One is we try relating that with one of the three generic formulas that we have: a plus b whole square, a minus b whole square, a plus a square minus b square. We see if it relates directly with that and convert into that form, and then we solve it for that. That is one approach. Second is we look at basically, any quadratic equation, the standard form for that is, okay. So basically the deal is multiply these two coefficients a and c and get the value of that and find out how will you break b to get the laptop keeps on getting logged in between, so that's what I think. So yeah, so basically you will multiply these two and then see how you can break b into two parts to get that. So in this case, let's say if you see 3 and 7, 21. This gives you 21, 3 into 7. Now, can you break 2 into two parts to get a 21? So you can say 21. How I can factorize this? It will be 3 into 7 or that's it. There is no other option. Or 1 into 21. So we cannot do, we cannot use this approach. So that's why he took the third option, where if you have a quadratic equation like this, ax square plus bx plus c, there is a given formula for us. It says from this equation, this will be minus b plus minus b square minus 4ac divided by 2a, where this is called the discriminant. If the value of the discriminant is 0, then you have only one solution because this part has become 0. If this value is greater than 1, then you have two answers for x. One is with a plus, one with a minus sign. So I'm not going to that, otherwise Dhanusri, Pranit, Srivatsa, Vaibhav, they'll be super upset with me. I have even Sunarka. Yeah. So but yeah, if these three approaches are clear to you guys, I'm not going to that. But yeah, net the thing is, if you have a quadratic equation, you can solve it for x, and that will give you the two values of the x-intercept. Okay. Vaibhav, you also took the same approach, right?
Yes, sir.
And I'm sure everybody else in the class who solved this problem would have taken that approach, because it was not in the form of this. Neither multiplying these two was able to break it into AB equal to A plus B form, and that's why we were leaning on the third option that gave us the two possible values of x. Now going back to the parabola. So here, this parabola gave us two values of x. What were those two values here? Yeah, Puneet, you can tell me.
I don't know these times. Roughly.
11 by 6 minus 7 by 6. So Pranit is saying 11 by 6 minus 7 by 6.
Those are like the rough.
Yeah, okay. So rough value. So 11 by 6 and minus 7 by 6. So here what we see, from this one what we see, the two x-intercepts are this way and the lowest value of y is below, minus 7. So this is facing upward. If I would have gotten these two intercepts like this, and the value of y would have been something like, or the y-intercept would have been touching somewhere on the positive side. So you cannot have parabola like this. It would have been something facing downward. Okay. So there is one more catch to it. Just by looking at the equation for the the quadratic equation, y equals to 3x squared plus 2x minus 7. Just by looking at this equation, I can say that this is facing upward. Do you guys know why?
A is positive.
Okay, I got one answer. Anybody on the screen? Just by looking at this equation without doing any calculation, without bothering about anything. Yeah, Arya.
I'm not sure if this is correct.
Uh-huh.
But is it because the leading coefficient is positive?
And the leading coefficient is positive. I am pretty sure you are taking me in the right direction, but let me hear Vaibhav also once. Yeah, Vaibhav.
I think she might be right, sir.
Okay, so as I keep saying that, right? You guys are much more intelligent than me. I'm a much more simpler guy. How will I do it? If I have an equation like this, I will always try to relate that with the standard form. Okay, this is the standard form. Okay, now if I relate that with the standard form of the quadratic equation, this is the standard form of the quadratic equation, right? You all know that already. Yeah, you can keep it here. Give it to me. Yeah, it's okay. It's okay. Yep.
I was doing a math problem.
Okay. So, sorry, somebody was at the door. So, if I have a quadratic equation, I will always try relating that with the standard form of the quadratic equation. And the standard form of the quadratic equation is like this: ax square plus bx plus c. My easiest catch is I look at the coefficients. Here, what is the value of a? Is 3. What is the value of b? Is 2. What is the value of c? It's minus 7. So just by looking at this, what we can see is the a, which I believe you guys are calling as a leading coefficient. I'm failing to recall, maybe I have overlooked that part, but yeah, in simple terms, the coefficient of x square, or the variable with power 2, is my a, and if the value of a is greater than 0, greater than 0, let's say, it is it greater than 0 or greater than 1? Greater than 0, right? Yeah. If it's greater than 0, this is facing upward. If the value of a is less than 0, this is downward. Now, you'll tell me how come you can derive that conclusion. First of all, we just saw one example here. With this equation, we were trying to draw the parabola, which was touching y-axis here, and these were two intercepts that we found. So we can still relate that. Now look at it a little more conceptually. If I have this equation, let's look at a very simple equation. I will knock off everything else. Okay? This is still a quadratic equation. Yeah? Everybody with me? Everybody awake?
Yes, sir.
Okay. Alright. So this is still a quadratic equation, right? And here, what is the value of a, b and c? A is 3, b is 0, and c is 0. See again, whatever I'm showing you guys, it is just to build that concept. It's just a way to relate things, okay? Now, this is my coefficient a, which I'm wanting to actually worry about, right? To see how a helps me decide whether it's upward or downward. Now, look at this. When a is positive, what does it mean? By increasing x, if a is positive, right? By increasing x, my y is increasing. Yeah? Because regardless of whether x is positive or negative, this part will be positive always. Whether x is equal to 2 or x is equal to minus 2, this part will be positive always. So it is the coefficient that decides whether y would increase or decrease based on increase or decrease of this one. Okay? Are you guys with me so far?
Yes, sir.
Okay. Now, when x is increasing or decreasing, whatever it is, this one, the value of y increases. How do we relate that? So, let's say here, when x is increasing or x is decreasing, my value of y is increasing. See, if x is 2 or x is minus 2, what is the, okay, let's look at an example here, okay. I want this concept to be cemented in your mind, okay, so that just by looking at the equation you would have no second thoughts. Let's say here, I don't know where the parabola is, but this is my equation. When x is 2 or when x is minus 2. When x is 2 and this is positive, right? So, what will be the value of y? When x is 2, y will be 4 into 3, 12. So, y is 12 when x equals to 2. So, let's say this is 12 and this is 2. So, this becomes my first point. When x is minus 2, when it's minus 2 and this is 12. This is my second point. Okay. Now, what happens? Where exactly is this is touching my x-axis? Meaning where y is 0? What am I saying? When x is 0, that means it's touching the y-axis. Now look at this. When x is 0, this is touching the y-axis here. What do you see? This will be facing upward. If this was minus 3, what would have happened? If a was minus 3, it was minus 3x squared. For the same scenario, when x was minus 2, it would have been x was minus 2, it would have been minus 12, it would have been here. But when x was 0, y would have been this. So, just by plotting some points here, right? When you pick any positive value or negative value of x, you see that these are the points coming in the first and second quadrant. When you make this negative, you see that this is coming in the third and fourth quadrant. And when you pick the 0 point, right, where it is intercepting the y-axis, you can see that, okay, this point is here. So, if A is positive, this is going this way. If A is negative, this is going this way. So, this was just an example to say that, okay, just by saying that the coefficient of x squared tells you whether it will be upward or downward, if A is greater than 0 or less than 0, would have not been sufficient. We just looked at one example here. And that confirms that, okay, this guy decides what is going to be my orientation for the parabola. Is it going down well? Okay. Vaibhav has heard it enough. I want to hear it from Heer, Shravya, Arya, Ananya, Snarka. You guys have not heard this story before. So I'm just trying to make sure that this correlation that we are trying to draw by seeing the coefficient of x squared being the decider whether the parabola will be facing upward or downward, whatever we saw just now, is it making sense?
Yes, sir.
You're able to relate, right? And okay, and again, see, there's no rocket science here, okay? I could have just stopped at this point and say, okay, fine, if you have a quadratic equation like this, if A is greater than 0, you can assume that it will be facing upward. If A is less than 0, it will be facing downward. That would have been the easiest thing for me to do. Why I'm still using some dirty techniques for proving that? Because I want you guys to believe this statement based on the example that we saw just now. Does that make sense? Okay. Now, if this is one form, okay? This is called the standard quadratic equation form. What are the other forms that you guys know about? Factor form and vertex form. So I can write the same equation in another form, saying, let's say a times x minus k into x minus n. What do you see here? This whole equation, quantity equation, I have put this in the form of two factors, three factors actually. Let's say this factor doesn't exist. If you look at the initial equation that I was talking about, 3x squared plus 2x minus 7. If I convert this into this form, okay, then that also tells you the 2 points where it intercepts the x-axis. That's it. Okay. Before I try going that far, the factor form that you look at, this is just another way of representing the quantity equation, and that also helps you derive a point based on how this form is converted. How do you relate it with that factor form is what I would want to go there, but before that, let me think how I want to put it. Okay, let me put the three equations or three forms together. One form is y equals to x squared plus bx plus c. Second form is y equals a times x minus l into x minus m. And third form is y equals a times x minus k squared plus b. So this is called standard form, which we talked about. This is called factored form, and this is called vertex form. So this part I'm not touching about now. Let's look at the second form. What is your understanding of this form? How does this form help you interpret something? I'll come to Pranit. I know Pranit has an answer for me, but anybody on the screen? What is your understanding of the this factor form, and how do you use that information for drawing some interpretation? Okay, Vaibhav is also ready. I'll wait to hear from somebody else also before I go to Vaibhav and Pranit. And again, I'm just trying to make sure everybody gets an opportunity to share what he or she knows, and we'll figure out if that understanding is correct or we need to fix something. Arya, Ananya, Heer, Sunarka, Shravya. Oops.
I don't really remember.
Okay.
This one.
Okay, that's fine. I mean, see, so that makes me happy, right? If there's something that you guys don't know, if I have to teach that makes me actually happy. So yeah, okay. I got one input. And where did Savya go? Okay. Anybody? Ananya, here, do you guys remember? What would be your interpretation of by looking at this factor form? Okay. Let me not drag this further because again we'll be pressed for time. So let's go to Pranit.
How would n where your x-intercepts where your parabola intercept the x-axis?
Okay. This is one information. Let's hear from Vaibhav also. Yeah, Vaibhav, what is your understanding?
So it's factorizing the standard form.
Yes. And what would be your interpretation by looking at this equation itself? See, I'll tell you, we don't really need so many forms. One standard form would have been enough. But when the mathematicians they kept on solving problem after problem after problem, right? What they did was, okay, fine. let me see if I can derive some interpretation out of it and put that or convert that to different forms to make life a little easier. So what Pranit was saying was, if I have a factor form like this, what it means is, see now you still have a, which is going to be a coefficient of x, okay? So if this a is positive, your parabola is facing upward, okay? I'm assuming that my parabola is facing upward for now. Now, this, if you are able to convert your quality equation to this form, right, or put that into a factor, what this means is L and M are the two coordinates where it meets the x-axis, where it intercepts, where the parabola intercepts the x-axis. You tell me why? Because, see, this is where, see, if L or M, the value of x equals to L or M, these are point L or M, when one of x is equal to L, let's say L stands for, L is 5, M is, let's say 6, okay, or let's say minus 5, I'm just making it up, or minus 6, let's say. What it means is, L is this point where x coordinate is equal to 5 and y coordinate is 0. This is where it's meeting the x-axis. Oops, you guys got locked out again. So L and M are two values of x where it's meeting the x-axis, meaning if x is equal to L, this part will become 0, eventually y will be 0. Hello Shanvi, you are a little early for the class. What is the time right now? We have still 8 more minutes. With the bigger kids, let me finish that class, then we'll start yours. Okay? Alright. So here, if x equal to L, that means the overall value of y will be 0, meaning it's meeting at x. Intercepting the x-axis. Similarly, if x equal to M, this part will become 0 and eventually the y value will be 0. So this is where it's meeting the x-axis. So when you look at this form, if you are able to convert your equation into this form, what that means is L and M are two values of x where this is meeting your x-axis. Everybody is quiet. I will go quiet as well. Let me wait to hear your reaction before I proceed.
I understand it, sir.
Okay. Everybody? Nanya here, Sunarka. Yeah?
Yeah.
Okay. So this is just, see, now let's make it simple first. When I had the quality equation like this in the standard form, we did all the magic with that, found the two values of s where it intercepts the y-axis. That's okay. People said, okay, this is more work. Let me make it easy for the kids like you all. They said, okay, if you can break this or convert this into a factor form like this, then L and M will be your two values where it is meeting this x-axis or intercepting the x-axis. Similarly, when you look at the third one, this is called vertex form. So before I go to the vertex form, let's look at one sample equation, okay? If I have an equation like this, x equals 3 times x minus 4 into x minus 3, let's say, okay? This equation has been derived, or this factor has been derived. If I look at this, right, it's x squared plus minus 7x plus 12 multiplied by 3. So 3x squared minus 21x plus 36. If this would have been my equation, then this would have converted to this factor actually. So you have this equation, you can break it into this, you can convert this into factor form like this. And as soon as you have the factor form, you have in the factor form, you don't really have to solve this equation. You can just, by looking at this equation, you'll say, okay, fine. This is x minus L. So L equals 4 and x minus n. Here m equals 3. Okay. So 4 and 3, these are the 2 points through which this parabola is crossing. Okay. Who got dropped off again? Now I think Srivatsa also got dropped off. Okay, alright. So just by looking at see when you have an equation like this, you can convert it into factor form, and that gives you a very meaningful information here. So for many of you, you will see that in the SAT exam, they'll just give you this equation and say, okay, find out where it is intercepting the x-axis. Very simple. You will just look at this is L, this is my M, and you will just pick it up. Now comes the third one. This is called vertex form. Yeah, pretty.
So this one shows where the vertex is, with x being what makes like that part is 0. X would be like, say k is -9.
Pick a chair, sit down.
You put x is 9 because that makes it 0. So then and then b would be the y of that vertex.
Right. So here, if you look at the vertex form, this tells you how many points, where does it, how much is the value of y, meaning the y coordinate of the vertex. If this is b, let's say if this is in the form of 2 times x minus 4 square plus 3. This means that this is the height of the y coordinate of the vertex. This is the y coordinate of the vertex, meaning the lowest point or the highest point, whatever it is. Since this is 2, this is positive, that means my parabola is facing upward. So this becomes my lowest point. The vertex is my lowest point. So the y coordinate of that is 3. Now, what is the x coordinate? This one is the x coordinate. The k is the x coordinate. Meaning from this equation, if you see, my x coordinate is 4 here. X minus k. So this k is 4. Now this picture is round. By looking at this equation itself, you will say no. First of all, I know this parabola is facing upward because a is positive, which is the coefficient of x squared. So this is facing upward. Now the x coordinate is 4 and y coordinate is 3 of the vertex, meaning vertex is somewhere here. This is 3, x is 4 and y is 3. So it's somewhere in the first quadrant. So this is the point. So the parabola is going like this. Okay? Hi Akshara. Akshara, you have joined probably 2 minutes early. I'm just finishing off my discussion with the senior students. Once they are done in other 2-3 minutes, then we'll start your class. Okay? Just stay there for 2 minutes. Yeah? Okay? Yeah. Actually, just give me 2 minutes. I'm finishing up the class with the senior students, and then we'll start your class. Alright. So now if you look at the 3 equations, the standard form, the factor form, and the vertex form. Standard form tells you standard quadratic equation which you can solve to find out where this is meeting x-axis, what is my y coordinate for the vertex, x coordinate for the vertex, that you can solve. This tells you a simpler form. Say, okay, fine. If you can convert your quadratic equation to this form, then this tells you where it's meeting the x-axis. And if you convert your equation to this form, then this tells you what is the x and y coordinate. This value of k is your x coordinate and the value of b is your y coordinate of the vertex. Vertex form. So it just gives you the information of the vertex. This is x coordinate, this is the y coordinate of the vertex. So you have, let's say, equation like this. Okay, I'll just take 2 more minutes. 2x squared plus 4x plus 7. Okay? What? Or let's say 8x plus 7. This. Okay? What you can do is, you can take 2 out, x squared plus 4x plus 4. So this becomes, and plus 1. Now you look at this. This becomes y equals 2 times x plus 2 whole square minus, plus 1. This is your vertex form. This tells you your x coordinate of the vertex. This is your y coordinate of the vertex, and you can find it out. So Salini, Aditi and Akshara, you guys will just wait for 2 minutes. I'm wrapping up the class with the senior ones, and then we'll start your class. Okay? Alright? Okay. So when you look at the 3 forms of the quadratic equation, this gives you information in 3 different ways. You can convert one form into another form and draw some interpretation from that and use that for, everybody sit down. Use that for doing further calculation or for easy interpretation from that information. Yeah? Any questions?